Hi everyone, welcome to the second video in the Arduino and 2 Thermistor data acquisition series. In this video, we're going to use MATLAB only to program our data acquisition system. In the video before this, we built the 2 Thermistor circuit from scratch, including voltage dividers and the LED warning light. But in this video, we're only going to be talking about coding and programming the Arduino in MATLAB. Okay, so to jump in, the first thing you'll need to download is the MATLAB support package for Arduino hardware. To do this, you just go to the Home tab of your MATLAB menu bar, and then you go down to Add-ons and click Get Hardware Support Packages. Then a pop-up from MATLAB should show up, showing all of the add-ons you can get. Or it'll show, are you up to date on your software maintenance? And I am definitely not, so I can't actually download this right now. So then what you would do is search for Arduino, and then click on the Support Package for Arduino Hardware and download it. Okay, now to the good stuff. We're going to take a function that takes the voltage read from the Arduino and turns that into a temperature using the Steinhardt-and-Hart equation. Okay, I'm just going to quickly go line by line and show you what might need to be changed for your specific thermistors. Here are the coefficients for our thermistor, and we took these from the resistance to temperature table on the datasheet for our thermistor. And then here's the voltage divider equation, which lets us know the resistance of the thermistor. And then finally we have the Steinhardt-and-Hart equation, which tells us the temperature from the resistance that we measured using the voltage divider. And that's where the coefficients, the Steinhardt-and-Hart coefficients, come into play. And so the only things to change based on your system are the Steinhardt-and-Hart coefficients, and they might even be included in the datasheet, or you can find them using the link below. Alright, so let's put it all together. In the final code, we'll use our circuit, the hardware support package, and the voltatemp function we just created. Okay, so I've just given myself a head start with a little bit of a header, my name and the date, and what I want to do with this. And I'm going to start out the script by clearing the workspace so I don't have any leftover variables or Arduino objects or anything like that. And then I'm going to instantiate the Arduino. And we do this using the command Arduino. It's included in the hardware support package, and you can find the documentation for that on the link below. Okay, so the first thing MATLAB wants to know is, what's the name of the USB port I'm supposed to connect to? So I always think it's helpful to pull up tmtool to find these random strings of letters and numbers that I can never remember. But it'll show you, if you click on serial, it'll show you a list of all the devices that are connected. You're looking for something with a USB or a USB modem in it, or USB serial. Okay, so I think I've found it, and I'm going to type it in as the first argument in a string. And then after that, I'm going to type in the model of the board. It could be Uno, Due, Mega, etc. But this one's an Uno. And that instantiates the Arduino. And now for the voltage divider, I'm setting the analog pins to their corresponding resistors. So if you watch the first video, our thermistors are around 10,000 ohms at room temperature, so I just used 10,000 ohm resistors. I didn't take the trouble to actually measure these, so I'm just assuming they're close to 10,000 ohms. And here I'm setting a pause between each reading, which gives MATLAB time to plot and also gives the thermistors time to adjust to different temperatures, so we don't end up with thousands of data points that are essentially the same reading. So I'm going to set the pause for 1 second. And now I'm going to set the number of readings I want to take and loops, and let's take around like 30 data points. Yeah, we'll take data for about 30 seconds. So before we actually start reading data, it's helpful to set up the plot figure. So title, labels, axes are sometimes helpful. And we do it before we actually start the reading loop so we can live plot our data onto that figure and see if maybe a thermistor is disconnected or resistor is disconnected. Okay, so now that that's done, we will start a timer, and we'll use the tick argument here and then the talk argument every time we want to take a timestamp so that we can use it as a time reading for each data point from the Arduino. Okay, so now we're going to start the main loop where we're going to do the voltage read, the conversion using the volt-to-temp function, the live plot, and the wait. So we start with a for statement. We're going to take 30 points of data, and our index we'll just call I. And here we'll take a timestamp using the talk function. And now we'll actually read the voltage from the Arduino using a read voltage function. And we'll read on pins A0 and A1. And at this point, we want to save these variables to a larger matrix. So at the end of all of our loops, we'll be able to save the data, print a figure, replot the data if something went wrong. I mean, we worked hard to take this stuff, so we want to keep it. Okay, so the first column is going to be the time reading. And then the second two columns are going to be the temperature reading. But if you remember, we just have voltage right now, so we actually have to use our volt-to-temp function before we put it into that array. And the volt-to-temp function takes the voltage that was read using the read voltage function, and then also uses the other resistor that's in the voltage divider. And then this function's vectorized, so you can use the VA array you made above, and then the resistor array you made at the top. It's just 10,000, 10,000. And now a quick if statement will turn on the LED if the temperature difference is ever greater than 3 degrees Celsius. The command to turn off and on digital pins on an Arduino is write digital, and then specify the pin. In this case, we're using the digital 5 pin, so D5, and then specify 0 if you want to turn the pin low or off, and then 1 if you want to turn it high or on. And this pin's default is going to be off, so 0. And at this point, we want to live plot our data on the figure we created before. So we already have a hold on and a grid on, so all we have to do here is just plot the data points that we want to plot and what we want them to look like. So for me, I wanted the first thermistor to be a blue circle, and then the second thermistor will be a red cross. And then for the pause, you could easily say pause parentheses wait, and it would just pause for 1 second, and your loop time would take 1 second and some change. But if we really need to have a loop that takes data every second on the second, and that's really important to us, we could do this pause time that shifts depending on how long the loop takes. So if the loop takes half a second, it'll only pause for the other half of the second. If it only takes a quarter of a second, it'll pause for 3/4 of a second. But at the end of the day, what we'll have is a reading every second on the second. Okay, so we're finished with our read loop. That's going to run for 30 iterations, and we'll have 30 points of data. So now let's say we want to print our figure and save the data after the entire read is completed. So we'll say print, first argument is some name, and then the format that we want to save to, and then the resolution. And now we're just going to save to a .mat file so we can access the data later. Okay, let's see how it works. So hit run, and error. What'd I do wrong? Okay. So I think I misspelled the port name. Oh yeah, that period's not supposed to be there. And while I'm here, I'm just going to add a axis command to set the axes of our live plot. Alright, let's try it out. Okay, looking good. Okay, got good response on the second thermistor. And on the first one. Great. Botched the save, or the print. Oh, it was the print. Oh, that's not a format. Okay, so we'll change that. We'll get you all saved. I won't put you guys through that read again. That's pretty slow. Let's make sure those work. And they do. How does it look? Oh, it looks good. Okay. Well, that's it. I hope you enjoyed this video, and I hope you build this circuit, test it in MATLAB, and that it works.